All right, and I'm not sure why the screen is not showing everything, but you've got the picture right in front of you. All right, this time the graph of f prime is sketched below, and its domain is the set of all real numbers. Use the graph to answer the following questions. Justify all of your answers in terms of f prime. The general rule is that you have to justify in terms of what was given to you. And this graph of f prime is what was given to you. In fact, I would suggest that in the middle of that graph, very prominently, you write f prime of x. Because all of these questions are asking about what f is doing, but that is the graph of f prime. So every time you look at that graph of f prime, I want you to be reminded that that is f prime. I don't want to get confused on that. All right, so A, over what interval is f of x decreasing? Well, if f of x is decreasing, what does f prime need to be doing? It needs to be negative. A graph being negative just means that the graph is below the y-axis, or the y values are negative. So what are the intervals where f prime is below the x-axis? Okay, negative 2 to 0 and 2 to 3. You do not need to put the union unless you want to put the union between them. All right, and then I have to justify in terms of f prime, so because f prime of x is what? Less than 0. All right, over what intervals is f of x increasing? What do I need to be looking for f prime? Where it's positive. Good, where f prime is positive. So from negative infinity to negative 2. And from 0 to 2. And from 3 to infinity. Because f prime of x is greater than 0. All right, where is f of x concave down? The first thing I think about with f being concave down is that f double prime is what? Negative. So if f double prime is negative, what's f prime doing? Decreasing. All right, so f prime is going to be decreasing from negative infinity to negative 1. And from 1 to, we'll call it 2.5. All of the other numbers on here are very clearly labeled, so that 2.5 is the only one that's even in question. All right, and then justifying in terms of f prime is because f prime of x is decreasing. If you write because f double prime of x is less than 0, you're not going to get credit because you have to tell me how you know that f double prime is less than 0. And it's because f prime is decreasing. All right, where does f of x have a relative maximum? Okay, it's where what equals 0? Okay, I'm hearing where the slope equals 0. The slope of what? The slope of f, the slope of f prime. Okay, it's where f prime equals 0. So that means that I have 4 relative maximums. Okay. F prime equaling 0 is a critical point, which would occur at negative 2, 0, 2, and 3. And critical points are starting places for mins and maxes. But a relative maximum is where f prime is changing from positive to negative. So at x equal negative 2 and at x equal 2. Is running out of batteries. All right, because f prime of x changes positive to negative. No, you don't have to write that f prime of x equals 0 because if f prime of x is changing signs, it's implied that it equals 0 at that point. Sure. At what value of x does f of x have a relative min? Okay, don't tell, someone said 0, 0. I'm just wanting to know what x values these are. And 0, 0 is a point on the graph of f prime, not a point on the graph of f. And it's asking for where does f have a relative min. So x equals 0 and x equals 3. And what's my justification? F prime of x changes what? Negative to positive. All right, f. At what values of x does f of x have a point of inflection? I want you to think about this. Think about what has to happen for a point of inflection and what the different derivatives mean, but you have to come back and justify it in terms of f prime. So don't call it out, think about it. Points of inflection are going to occur at -1, 1, and 2.5. And here's my reasoning for it. Points of inflection occur where the graph changes concavity or where f double prime changes signs. If f double prime is changing signs, then what's f prime doing? Changing the signs of your slope, or changing from increasing to decreasing, or vice versa. And that's going to occur at a relative extrema of f prime. So your justification can be one of two things. You can write because f prime changes from increasing to decreasing, or vice versa. Or you can say because f prime of x has a relative min or max. Those are your only two options. Telling me that f double prime changes signs is not acceptable because you're not justifying in terms of f prime. You can't say because f prime equals 0, which in this case it does, but there's not always a point of inflection everywhere that f prime equals 0, because f double prime needs to be changing signs. So those are your only two options. F prime changes from increasing to decreasing, or vice versa, or f prime of x has a relative min or max. You don't have to write both, just choose one or the other. Okay, and then lastly, G is to sketch a graph of f of x that contains the point -3, 1. So obviously we want to put -3, 1 on this graph. And it says to sketch a possible graph. So there are lots of different options here that you can do. Personally, I would probably kind of start with your mins and maxes. So we know that we have and you could also think about increasing or decreasing. That might be the easiest thing to start off with. So we know that f of x is increasing from -infinity to -2. So therefore, I had a maximum at -2. I don't have any idea what the y value of that maximum is, and it doesn't matter. I can put it anywhere up above the point -3, 1. All right, and then my function f is going to decrease until I get to x equals 0, and x equals 0 is a relative minimum. I don't care where you put this relative minimum as long as x equal 1 is lower, sorry, x equals 0 is lower than x equal -2.
Why did you have -3, 1?
Because it told me that sketch a graph that contains the point -3, 1. All right, and then between x equals 0 and 2, f is increasing again, and I have another maximum at 2. Now I could make my hill here, or I could make it way up high. I mean, it literally does not matter where you make this hill at x equal 2, because we're just sketching a possible graph. And then I have another minimum at x equals 3. I'm going to go down below the x-axis just because I can, but I don't have to. And now if I just connect all of these points, like that, I'm going to have it. And I need to put arrows on the end of it because it told me that the domain of my derivative was all real numbers, so therefore the domain of the function is all real numbers. It doesn't. It needs to go back up, thank you, because 3 was a minimum. So that shouldn't be here. The other thing you need to take into consideration here is your concavity. And I have points of inflection at -1, at +1, and then at about 2.5. So when you go back over this, you just kind of need to make sure that you are communicating that your graph is changing concavity. And you can look back at your intervals that you wrote above. But the graph is concave down from -infinity to -1. I've displayed that pretty well. Then I switched to concave up. And I've displayed that pretty well. Could probably do a little better job. And then from 1 to 2.5, the graph is concave down again. I could probably do a better job there. And then concave up from 2.5 to infinity. And once again, it's just a possible sketch of a possible graph of f of x. There are lots of different ways that you could make this look, specifically where the y values of all of those mins and maxes are.
There are two things that I want you to remember when you're working these problems, and you can write this down wherever you want, just kind of on the side of your notes. But the first thing is that you always have to justify in terms of what was given to you. For example, in this last problem, f prime, the graph of f prime is what was given to you. So you have to, every single justification has to be in terms of f prime. Throughout the rest of this assignment, sometimes in the general directions for the problem, it says be sure and justify your answers. And then sometimes next to each letter, it says justify your answer. But when in doubt, justify. On these types of problems, you're pretty much always going to have a justification. So justify in terms of what was given to you. The other thing is pay attention to the domain of the problem. This last problem, the domain was all real numbers. And so therefore, that first interval, we started with -infinity until whatever that first min or max was. But I believe on the next problem of this homework, the domain is like just between -4 and 1. So just pay attention to the domain and make sure that if there are endpoints of the original problem, that all of your answers are within that domain. And if the domain is all real numbers, then your intervals will begin and end with -infinity and +infinity.